How do you interface sensors with microcontrollers effectively? In today's fast-paced world of technology, the question on many engineers' minds is, how do you interface sensors with microcontrollers effectively? With the rise of smart devices and automation, this topic has gained significant attention recently. Many professionals are seeking practical solutions to connect sensors to microcontrollers for their projects. Let's break down the essential steps to achieve this connection smoothly. First, it is crucial to understand the type of sensor you are using and its output signal. Sensors can provide either analog or digital outputs. For example, temperature sensors like the TMP36 or LM354 output a voltage that corresponds to the measured temperature. This voltage must be read by the microcontroller's analog to digital converter input pins. On the other hand, digital sensors communicate using protocols such as inter-integrated circuit, serial peripheral interface, or universal asynchronous receiver-transmitter. Next, providing a stable power supply and ground reference is vital. Most sensors requiring a power supply of 3.3 volts or 5 volts, often supplied by the microcontroller board. Connecting the sensor ground to the microcontroller ground is essential to avoid measurement errors, especially with analog sensors. Signal conditioning is another important step. Some sensors output signals that may not be directly compatible with the microcontroller's input range. For instance, microcontrollers typically accept only positive voltages. If a sensor outputs negative voltages, a direct current offset can be added to shift the signal into an acceptable range. This technique is commonly used in low-cost sensor circuits, ensuring the microcontroller reads valid positive voltages. Using the appropriate input pins and configuring general-purpose input-output pins is also necessary. Microcontrollers have dedicated input pins for analog signals and digital signals. Properly configuring these pins ensures accurate data acquisition. For example, the STM32F030C8 microcontroller offers multiple pins that can be set as analog inputs or digital inputs and outputs. After connecting the hardware, programming the microcontroller to interpret sensor data is essential. The microcontroller must read the sensor data, convert raw values to meaningful units, and handle communication protocols if applicable. This allows for effective monitoring and control based on sensor inputs. Lastly, consider environmental and electrical noise factors. Sensors and microcontrollers should operate within specified temperature ranges to maintain reliability. Proper shielding, filtering, and grounding help reduce electrical noise and improve signal integrity. By following these steps, selecting the right sensor type, ensuring stable power and grounding, conditioning signals appropriately, configuring microcontroller inputs correctly, and programming accurate data interpretation, you can successfully interface sensors with microcontrollers for various applications such as automation, robotics, and energy monitoring.